Hi class, hope you're doing well today. Today's presentation will be on classification and SI prefixes. Now classification of matter and SI prefixes are chapter 1 is something we went over in August, and it's always good to go back to the basics. Here we have a small SI prefix chart and a small flow matter chart. Next. So, the definition of matter is anything that has mass or volume or takes up space. Now, today's presentation will be primarily vocal. For example, most college professors don't do visual presentations. You have to take notes and find the most important things from what they say, and that's the method that we'll be using today. So today's objective is to distinguish the difference between matters and memorize the 9 prefixes. So here we have a larger, more in-depth chart. At the top is matter. Then we have pure substances and mixtures. Some might ask what the difference is, and the difference is mixtures can be physically separated and pure substances cannot. Pure substances are chemically combined and no longer have distinct composition and distinct properties. It's mixed. And mixtures, however, are consisting of 2 or more pure substances that retain individual identities and can be physically separated. Now, these 2 pure substances and mixtures can also be divided into 2 more. So pure substances have under it elements and compounds, but under mixtures is homogeneous and heterogeneous mixtures. Now, elements can be described as a pure substance consisting only of atoms that have all the same numbers of protons in their nuclei. So it's identical, nothing's different. Whereas a compound is something that's made of 2 different things. Now, with a homogeneous mixture, its composition is uniform. It's always going to be made up of the same things. That's why it's homo. Whereas hetero, which is 2 things, is a mixture of 2 components. And then we have our common prefix and SI units. Now, SI units represent multiples of 10 to the power as a way to convert. These are examples of matter. The periodic table of elements would represent elements, obviously. Atoms, molecules, and compounds. This is just a small example of compounds. Compounds are 2 different things that are made into one. Then we have heterogeneous mixtures, basically 2 things that are put together but could also be taken apart. So cookies, you'd have the dough and the chocolate chips, you can take those apart. Pizza, you have the different ingredients, you can take those apart and have them not be mixed at all. Whereas homogeneous mixtures, they are the same things mixed together. So brass is all brass, blood is all blood, natural gases, coffee is just coffee, wine is just wine, well, fermented grapes. And air, technically air is a mix of oxygen and nitrogen, but just for example's sake, air. Then next, we have a more in-depth example of SI prefixes. We have mega, kilo, the base unit, deca, centi, milli, micro, nano, and pico. Each prefix is represented by a symbol, and mega symbol is M, kilo is K, base unit does not have one, deca is D, centi is C, so on and so on. And each prefix and symbol has a factor. The factor is 10 to the power of whatever number that the words represent. So 10 to the power 6, 10 to the power 3, 10 to the power 0, and so on and so on. Over here, we have a chart that represents a good way of memorizing how to convert. So King Henry died unusually drinking chocolate milk. So kilo, deco, deca, unit, deci, centi, milli. So these are different units and different ways to convert those units to the appropriate SI prefixes. And that basically covers our whole presentation. If you have any questions, you can email me.